In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths paper 3.3. I'm going to try and show you how to do this question and not just the solution. So you may need to pause and rewatch certain parts of the video. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. In question 5, part A, they give us this equation to start with, and they also give us dy dx is equal to a big mess. Now, I haven't wrote that down because they often do this. They want you to show that happens. They do that just so you have that question ready for part B in case you can't finish part A. I think it doesn't help students. Well, it does later in the question. It can sometimes distract students seeing it there. So I say don't put it there yet, just try and get it. Later on in the question, when we get close to being finished, we go, okay, does it look like what they wanted it to look like? Often you have to, which we will have to in this question, often you have to readjust it slightly. So really they want to find dy dx. That's what I take away from show that dy dx equals. Just find dy dx. What you'd like to do here is find y equals and then just differentiate. You can't do that, it's too complicated. The y is too mixed up in this. You'd have to use the quadratic formula and it'd become a whole mess. What we can do is use implicit differentiation. What that means is we can differentiate both sides. So we'll just differentiate without a subject. So usually it's dy dx because we're differentiating y. Or it's, if you were differentiating x squared, you might write dx squared with respect to x. In this case, we're just going to differentiate the whole left hand side. So let's just put it in a bracket. Y squared e to the minus x. And to be equal, we're going to differentiate the whole right hand side, which is just 4. This right hand side is going to be nice and easy to do. It's the left hand side that's going to give us a good bit of trouble, but not too bad. First of all, differentiation works sort of like multiply. We can take each of these separately. So I can already separate this out as we're differentiating xy plus we are differentiating y squared e to the minus x. What we have here is the product rule. We have two things multiplying. Now they're difficult things to do, but they're still just two things multiplying. The right hand side, let's just do right now. The derivative of a constant is just 0. How much does x change when 4? It's 0. It doesn't change at all. How much does x change when this changes? Yeah, probably a good bit. Okay, how do we do this? Product rule. I just differentiate the first thing. So I get 1. And I leave the second thing alone, multiplied by y. Plus I leave the first thing alone and multiply by the derivative of the second. How do you differentiate y? It's just dy dx. This is the secret of implicit differentiation. This is what we want to get. We'll see what we do with it in a moment. So that's a derivative of this as best we can do. This one's somewhat similar. It's two terms. Let's differentiate the first one. So this is this plus here. I'm putting differentiate the first one. That's hard in its own right. What's the derivative of y squared? Well, we use the chain rule. First we assume that we're differentiating with respect to y. So y squared becomes 2y. But that's a bit of an assumption. That's what the chain rule does. We're sort of saying, forget doing it by x. Let's do it by y. It's much easier. But we can fix it. Let me just write that over here. D y squared here is what we're trying to do in the middle of this question. That's the same as doing y squared with respect to y. That's the cheat I'm doing. Once I fix that cheat with dy dx, basically these dy's cancel. So here, instead of differentiating the first part, y squared, with respect to x, I get 2y. I differentiate with respect to y. Now I need to multiply it by dy dx. That was all just this guy differentiated. Then we leave this one alone. That's the product. We're back in the product rule at the moment. Next, we leave this one alone. So plus we leave that one alone, and we differentiate this one. We can also think of the chain rule. Differentiate with respect to minus x instead of x, or you can just look up certain rules of differentiating with something multiplied by x. Either way, we get I think of it as the chain rule. I think of it differentiate with respect to minus x, so it just means nothing happens. but then we have to multiply by the derivative of what's up here, which is just minus 1. So this gets multiplied by minus 1. So we'll just change that to a minus. Okay, let's clean this up. Oh, sorry, this is all still equal to 0. Let's clean this up as best we can. Actually, there's not much to clean up, so let's already skip to the next step. We want dy dx, and there it is. So let's just get it on its own. Let's isolate it. dy dx has a few things going into it. Dy dx, and this one has x going into it. And here it has 2y times e to the minus x. And let's move everything over the other side. This becomes y squared e to the minus x, this term here. And this one becomes minus y. Let's divide both sides by that and we get dy dx on its own. dy dx is equal to y squared, e to the minus x minus y divided by x plus 2y e to the minus x. We're done. We just want to double check that's what they wanted us to find. And unfortunately it's not. It's not quite. It's close. They wanted a y squared minus a y. They wanted an x plus a 2y. So we're very close. Just all these e to the minus x's. They're not where they should be. They have e to the x here and here, not here and here. So what's going on? Let me just clear the board so I have a bit more room to show you. So let me rewrite this over here. But instead of e to the minus x, I'm going to write that as divided by e to the x, because that's what that minus does. So this minus y, there's nothing special about that. Divided by x, there's nothing special. But this 2y, he gets multiplied by e to the minus x. So that's the same as divided by e to the x. I could rewrite that, this here as that. The problem is, we don't like divide. We don't like dividing by things, so let's get rid of it. To get rid of this, we multiply everything, top and bottom, by e to the x. So e to the x on the top, e to the x on the bottom. We can do that whenever we want because, look, it's like multiplying by 1. This divides that. It's like multiplying by 1. But here's the great thing it does. It multiplies by both of these. Multiply by that, we get just y squared. These cancel. Multiply by this, we get minus y e to the x. That's what they have on their top row. On the bottom row, we get this by that. That's x by e to the x. That's what they have. And this cancels with that. And we get plus 2y. And that's how we get the equation they had. I think they'd take a mark down here. I'd like to say they'd only take half a mark. But I'm not sure they're even allowed to do that. But I think they should only take half a mark. But you might lose a whole mark for that. Okay, let me clear off the board and we'll do part B. Before we do part B, let me just go back to part A for 1 second and point out a little cheat you could probably get away with. I said if you left your answer what we had here, you might lose a mark, half a mark. A nice little cheat would have been, you knew the answer should be this. You knew it looked close to that. You could just wrote equals this, and the examiner would probably have gone, yeah, okay, you did it all in your head, that's fine. It's a bit cheeky, you won't get away with it all the time, but in that case you probably would have saved yourself losing a mark if you didn't know how to get from that step to the one I wrote over there. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Anyway, let's on to part B. Part B, also remember in part B, if you weren't able to do part A, you're back in the game for part B. All you need is these two equations and they gave you that in part A. So even if you didn't get anything in part A, you can do part B. They want you to find the gradients of the tangent to the curve. This is the curve. The gradient is this. dy dx is the gradient. They just want dy dx when x equals 0. So you could try, this is going to be wrong, but you could try doing this, dy dx when x equals 0. Just put it in. We get y squared minus e to the power 0 is 1. So we get minus y over 0 times anything is 0. That's gone. Over 2y. So maybe that's your answer. You might get a mark for that. But no, they want a number. This isn't right. I'd love to know what y is equal. So what we should have done at the start is find out what y is equal. We have everything we need here. There's an equation with two unknowns, and they told us what x is. So we've one unknown. Let's write this equation out again. 0 times y, 0, plus y squared, e to the power of 0, just 1. So what do I have? Plus there. Y squared basically we have. This is 0, this is 1. We have y squared equals 4. We have y is equal plus or minus 2. And that is important that you get the two answers there. Not one answer, two answers here. So instead of x equals 0 putting in, we want to put in y equals 2. And then, yeah, let me do it down here. And then down here we'll do it again. Just do it all over again. X equals 0 and y equals minus 2. And we get two answers. So this one, we've already done most of the work. We put 0 in for x. Let's put 2 in for y. That becomes, what's that? Sorry, that's 4 minus 2 over 2 times 2 is another 4. It's 2 over 4, which is the same as 1 over 2. That's an answer. That's one of our answers. They ask for gradients of tangents. So they want more than one answer. There's one of them. The other answer, let's do this straight from the start. Minus 2 goes in here, it would be 4. Minus 2 squared is 4. Minus 2, that's plus 2. E to the power 0, that's 1. So plus 2. Bottom row, we get 0 times anything, it's gone. And then 2 times minus 2. That's minus 4. This is equal to 6 over minus 4, which is the same as 3 over 2, or sorry, minus 3 over 2. There are your two answers. The gradient's either half or minus 3 over 2. And that's it for question 5. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.